Okay, good. So if I rotate it 0 degrees, does anything change? No. So my point is just going to be -6, 1. Nothing changes if I rotate it 0 degrees, okay? But let's say I rotate it 90 degrees, okay? If I rotate it clockwise, you guys tell me which direction is this going to spin if I rotate it 90 degrees clockwise? Imagine you're like doing your locker combination, right? Yeah, I'm going to the right, so I would spin it to the right, okay? So I want to spin that red dot to the right 90 degrees, okay? So when I do that, I'm going to come up with a point roughly about here, such that I'm doing it about the origin, and if I draw a line from my point to the origin, and then from the origin to my new point, it should form a 90-degree angle, okay? So that point, I'm just going to tell you, is going to end up at the coordinate point 1, 6. Okay? So if I rotate it 90 degrees, I end up with the coordinate point 1, 6. Okay? Now, if I rotate that 90 more degrees, so if I rotate it 180 degrees, what that means is I have to form a straight line with the origin from where that point was initially to where it'll end up. So that means it would end up somewhere around here. Okay, so this is my next point, because that would be a 180-degree rotation about the origin. Okay, so you guys tell me, what coordinate point would that be, would you expect? Almost. 6, -1. So it'd be the point 6, -1. Okay? All right, now if I did 270 degrees, that's 90 more than 180, right? So I'm thinking right around here would be that value, okay? What's that coordinate going to be? Good, -1, -6. If I rotate something 360 degrees, what happens? Good. It's back at its original position, right? Or its origin, I guess you could put it that way. So that would also be -6, 1. Okay? Now, what our job is to do is to compare this value right here that I'm boxing in to each one of the values that we ended up with, and then coming up with a rule for each one. Okay? So what happened if I went from -6, 1 to -6, 1? Did anything change? No. So then I would just say xy is the same as xy. Nothing changed. What about -6, 1 to 1, 6? What happened? To get from here to here, what did I do? Angeline? It's -yx, meaning I flipped my coordinates, and then I changed the sign of the one that landed in the second spot. So actually it would be y -x, but you were really close. It's y -x. You flip it, and then the value that lands in that second spot is what changed sign. So y -x. Okay? All right, what about to get from 6 or -6, 1 to 6, -1? What happened there? Switch signs of both x and y. So xy becomes -x. Good. -x, -y is what that becomes. I feel like it's a little hard for you guys to read, so let me thin this out a little bit. -x, -y. Okay, cool. All right, what about 270 degrees? -yx. That's the one that Angeline was talking about earlier. Julia, you're right. It becomes -yx. So it means your coordinates change sign, or change, they flip, they swap, and then you change the sign of the one that lands in that first spot. What about 360? Does anything change? No, so that would just be what? Good. Okay, cool. So that's for that specific example. Let's go ahead and fill out this table for your ordered pairs. So that's clockwise, okay? So we said 90 was y, negative x. 180 degrees clockwise was negative x, negative y. And then 270 degrees clockwise was negative y, x. All right, let's do counterclockwise. Okay. How do clockwise and counterclockwise compare to each other? It's just the opposite way you spin, right? So instead of spinning to the right, we're instead going to spin to the left. What does that mean? These locations are going to end up being very similar, right? What if I rotate something 180 degrees counterclockwise? Is that going to change where it lands compared to clockwise? And then it'd be in the same spot, right? So then this is just going to be negative x, negative y. What would you expect to happen for the 90 and 270? They would switch compared to what they were for clockwise, right? So for example, like a 90 degrees clockwise rotation will be a 270 degrees counterclockwise rotation. So that means down here would be y, negative x, and then 90 would be negative y, x. You got to memorize them. These ones you got to know. It's a good time to make flashcards. So if you're a flashcard kind of individual, this would be a perfect thing to put on a flashcard. Counterclockwise 90, on the back you put negative yx, okay? If you're not a flashcard kind of person, this would be a good time to try it out. Or try at least some sort of method of studying, because these I'm going to expect you guys to have memorized. When you have them memorized, it's pretty simple. Then you just need to remember what the rule is and then apply it to whatever you're given. But you got to have memorized, okay? Most of the time, our rotations, we will assume, like if they don't tell you a direction, we will assume that it is counterclockwise, because that's the convention in math, is that you rotate something counterclockwise. All right. All right, here we go. The triangle's vertices A, B, and C. Find the coordinates of a 90-degree rotation that is counterclockwise about the origin. Okay? Let's plot our original, and then let's do the rule and find out what our new points will become. So A is at 1, 2. B is at 3, 7. I should wait to write my points. And then C is at 5, 5. A, B, and C. All right, so then now what I want to do is I want to rotate it 90 degrees counterclockwise. So real quick, I'm going to write my rule up here. So 90 degrees counterclockwise. Write all that if you want to. You don't really have to. But our rule is x, y goes to what? Look back on that last slide if you need to. So now 90 degrees counterclockwise. I look back at my last slide and it's right here. Negative yx. Okay? So then I write that rule up there, negative yx. Which means to each one of my coordinates, a prime, b prime, c prime, I need to switch the x and y and then change the sign of the one that lands in the first spot. Okay? So my first point is 1, 2. What will that become? You said what, Ryan? Do you guys agree with Ryan? Negative 2, 1? Sounds good to me. All right, my second point is 3, 7. Someone else, what will that become? Good, Julia. All right, my last point is at 5, 5. What's that become? That's the easy one.
Negative 5.
Good, Clark. Cool, let's plot. All right, so then negative 2, 1 is right here. And then negative 7, 3 is right about here. And then C is negative 5, 5. Oops. So negative 5, 5, which is like right over here. Does my red triangle look like my black triangle rotated 90 degrees about the origin? So A was negative 2, 1. This is A prime. B prime was negative 7, 3. B prime. And then C prime is up here. Which means to each one of these points, what I could do is I should be able to connect the original point. Oops. Connect the original point to the origin and then connect it to my point that I ended up with, and it should be a 90-degree angle. So for example, from here to there, does that look 90 degrees? Should. From here to there, that one's a little tough to see. Does that look like 90 degrees? Should. And then from here to there. Those are all really tough to see, but they all look like 90-degree angles to me. So because of that, I know I did my rotation correctly. Okay? So that's what I want to see. I need those new coordinates. All right? Questions there? Okay. All right, let's do example 2. We've got a new set of vertices. Now we're rotating it 180 degrees about the origin. Doesn't say counterclockwise or clockwise, but does it matter? Not for 180, because it's going the same direction, right? Okay, so X, Y, I use the rule for 180 degrees. What is that rule? X, Y goes to what? Go back to your slide if you need to. 180 degrees, X, Y turns into what? Good. So I just need to change the sign of all my coordinates. This is the easy one. D prime, E prime, F prime. Okay, so then negative 4. E is at negative 4, 6. So it would become 4, negative 6. And then F is at negative 1, 7. So that's going to become 1, negative 7. Okay? All right, let's plot my original. Plot my original in blue. So then negative 2, 4 is D. E is at negative 4, 6. It's E. And then F is at negative 1, 7. So D, E, F. All right, so then my new points. D prime is at 2, negative 4. 1, 2, 3, 4, okay. It's D prime. E prime is at 4, negative 6. I don't like where I wrote that, like a dummy. So then D prime, E prime, and then F prime is at 1, negative 7. 6. Okay. Does my red triangle look like my blue triangle rotated 180 degrees about the origin? What do you guys think? That looks good to me. If I connect all of my values for D to D prime, I should be able to do so with a straight line, because it's 180 degrees, that passes through the origin. So there's D. There's E. And then there is F. So those all are a straight line that pass through the origin, so I know I did it right. Okay? It's like a cool little visual. All right. Questions there? We doing all right? Okay. All right. Now, with this next one, we've got a set of points, and then its image as well too. So we got a pre-image and an image. We want to write a rule. So we want to figure out what rotation are we doing. Okay, is it clockwise, counterclockwise, and then what degree is it? Okay, and really you could have two answers for this one, but let's go ahead and let's plot what we have. So A is at -2, 3. B is at 4, -5. 1, 2, 3, 4, 5. Messing with my eyes. And then C is at 2, 6. Okay. So this big blue triangle is my original. Okay. So we'd say this is A, B was down here, and then C was up there. Okay. Let's plot our image and then see what we get. Okay. All right. So A prime is at -3, -2. And then B prime is at 5, 4. And then C prime is at -6, 2. Okay. We need to try to say what happened here. Clearly not 180, right? Okay, so it's either 90 or 270. And honestly, it could be either 90 or it could be 270. You just have to be smart about which way you are saying it reflects. What do you guys think?
90.
90 clockwise? 270 what? Well, I would say this. If I'm rotating this 90 degrees, I wonder if I wish I could select. Yeah, I can't do that. If we are rotating this blue triangle, let's say, I would say this, like, in my brain, like if I'm not demanding which way you guys go, clockwise or counterclockwise, I'm looking at like what way is it closest. So if I did this blue triangle, in order to get from the blue triangle to the green triangle, if I spin it to the left, I don't have to spin it very far. Do you guys agree? I could just take this and spin it like that, and then I would end up there, okay? So that would be how much of a degree spin if I spin it to the left. 90, what direction? Counterclockwise. So it's either going to be 90 degrees counterclockwise, or if I did it clockwise, I would have to take this and like this point A, I'm going to have to spin it like all the way around before I get to that point. So it's either 270 degrees clockwise or 90 degrees counterclockwise. So I'm going to say, not with that. I'm going to say 90 degree, what do we say, counterclockwise. Okay. Tegan, you with us? My man is tired. Tegan was on the game too late last night. No, you're just FaceTiming with your lady or what? You're just tired. Okay. All right. If a figure can be rotated less than 360 degrees about a point and have it line up exactly on its original pre-image, then that figure has what is called rotational symmetry. So if I can take a figure and I can spin it and line it up exactly on the same orientation that it was before, and it lines up exactly, then we say that it has rotational symmetry, okay? And then the amount of possible rotations that you can have represents the order according to how many possible rotations of less than 360 degrees, including 0, that produce an indistinguishable image, okay? So what that means is, if I start with this, what type of shape is this, by the way?
Pentagon.
It's a pentagon. If I start with this pentagon, how many times can I rotate it such that I'll land back in its original spot? 5, right? So I can rotate it once and then again, and you see like the numbers of the angles can change. However, that's okay. I'm just concerned about the blue lines, okay? But there's 5 ways, because including 0 degrees, then it would be 5 ways, okay? So what order is this? We would say it's an order of 5. Now, what degree rotations would that be? So how many degrees would I have to rotate this first one so that way it looks like the second one? I guess we're going counterclockwise, but how many degrees would I have to rotate that? How would I figure that out? It's not 90. That's a good guess, though. If you rotate this thing 90 degrees, then this point would be like exactly in the middle, so it would be a little more tilted. If you don't believe me, take your iPad and rotate it 90 degrees. Does that look exactly like the piece that we ended up with? No, it does not. Okay? So how would I figure that out? Man, that was one of the most brilliant things you two have ever said. We're going to take 360 degrees and we're going to divide it by 5, okay? Because each occurrence of that would be how many times we can rotate it in order to line back up on itself. So 360 degrees divided by 5 gives me what? 72? So then this would be 0 degrees. This would be 72 degrees. What would this next one be? 144. And then I don't know what 72 plus 144 is. 216? No, it's not. It's 216. And then 216 plus 72 is 288. And then if I did 288 plus 72, that would get me back to 360. Okay? All right, good. You said what? It says 288. All right, questions there? You ready to do some dilations? What does it mean if you dilate something? Bigger or larger, right? Or, yeah. Bigger or larger, that's the same thing. Bigger or smaller, okay? You change the size of it. How many of you have been to the eye doctor and they dilate your eyes? You ever do that and then walk outside?
You gotta wear the glasses.
It's brutal. I remember one time I had an eye doctor appointment before work. And I was like, it was one of the appointments where they had to dilate my eyes. And I was probably your age. No, I was driving. So I was probably like 18 or 17 or whatever. So I'm like, I go to the eye doctor. I get my eyes dilated. And I didn't even think about the fact that I like drove myself to the eye doctor and like took myself to the appointment. And then I had to drive afterwards. That drive home, it was like the sunniest day. And I'm like, I don't even think I had prescription sunglasses at the time. So I was just like wearing the thing that they gave me. It was brutal. Like I thought my eyes were going to catch on fire. And then I remember I like went home and like I ran up to my room and like shut my blinds and turned off my lights and just put my face in a pillow and just like closed my eyes. And I was like, ah, it was a nightmare. Anyway, dilations. Why do they dilate your eyes at the eye doctor? Why do they look inside of it? Yeah, what are they actually looking at? Yeah, they're looking at the back of your eye when they do that. And when they dilate your eyes, the black part of your eye, which is just a hole, by the way, opens up more so more light can go into your eyes so they can see the back of your eye better. Yeah, it's just a hole.
Was it blurry for you? Is it blurry?
We learned something today, right? But that's why your eye is black in the middle. It's just a hole.
A hole?
Yeah.
It's a circle.
I don't know what shape it would be. It's an oval. Yeah, it's still brutal though. But either way, so that's what they're doing is they're dilating it. They're making that opening larger so they can look in the back of your eye. Okay? We learned something today. Okay, but we will talk about dilations getting bigger, and then we'll also talk about a dilation getting smaller as well too. Okay? All right, so a dilation is a transformation that changes the size of a figure. It requires a center point and a scale factor K. So we'll dilate some things about a different center point, but today we're just going to focus on the origin, okay? The scale factor K tells you how much the object has changed, okay? So K is your scale factor. Oftentimes these problems will revolve around a scale factor, okay? All right, so a dilation with a center C and scale factor K, K greater than 0, K can't equal 1 though, is a transformation with the following properties, okay? So the two properties are the image of C is itself, so same as itself. And then for any other point R prime is on CR, and CR prime is K times CR. So basically, you just need to use your scale factor to get to that value. So for example, if we are dilating this triangle about this point, it's almost like a projection, okay? So we would see there's two types of dilations that we'll talk about. Just in layman's terms, tell me what's happening to this triangle. It's getting bigger, right? Okay. All right, so if your absolute value of your scale factor is greater than 1, what would you expect the dilation to be? Do you think it's going to get bigger or smaller? If we're multiplying it by a number that's bigger than 1. Probably bigger. So what we would call that is an enlargement. Okay. If the absolute value of your scale factor is in between 0 and 1, but not equal to 1 itself, then what would we say the dilation is? Is it getting bigger or smaller? Smaller. So we're going to call it a reduction. Sparrow.
Yeah.
If I were you, I would have your notes open and following along what we are doing. Okay. All right. Now, if the absolute value of K is equal to 1, then it doesn't change what it ends up being. So, okay. All right. Let me give you, hold on. Sorry. Homework at the bell. I'm not going to have you guys do anything with dilation. Good shot. So what I'm going to do is I'll tell you what problems to do on Google Classroom. You'll just do the ones with the rotation. Sorry guys, I didn't realize what time it was. I apologize. No, we're not doing all of them though. I'll tell you what problems to do in a second. I just want you guys to do only the ones that's about rotation.
Yeah, people are already doing it.
Yeah, but everyone left.
Posted on Facebook.
Well, I said I'll post it on Google Classroom, so.
Oh, really?
Honestly, it's just gonna be the first page. Oh. So just do the first page, 1 through 6.
I,
You too, buddy.
Are you ready for another amazing class today?
Oh. I would expect nothing less from you guys.
What are you dressed up for?
Tuesday? That's it.